So if we have an issue with salinity or sodicity, how do we actually classify it? And this is why in the previous several videos, I introduced to you exchangeable sodium percentage or saturated sodium adsorption ratio or electrical conductivity. And so the way that we classify soils that may be affected by salts or sodicity, sodium, is we typically use electrical conductivity to determine if there's a salt problem in the soil. And then we use exchangeable sodium percentage or SAR, sodium adsorption ratio, to determine if there's a sodium problem. And in conjunction with these measurements, we need a measurement of pH. And so there's a table that I'm sharing with you that tells you or shows you the classification of 4 different types of soils, what they are equivalent to or why they are this way in terms of electrical conductivity and ESP or SAR, and soil pH, and then the soil condition in terms of the physical condition that you would actually see. So let's go across this table starting from, let's start at the bottom. A normal soil has a very low electrical conductivity, and it has a low exchangeable sodium percentage, less than 15. I think I may have told you 5 in a previous video. We're shooting for less than 15. And a relatively low pH, all right? So plants typically can survive up to about pH 4, 8.4, maybe 8.5, right? These types of soils where where overall salts are low, where overall sodium is low, and the soil pH is in the range where most plants can survive, this soil is classified as normal, and it would look normal, right? So let's start at the top now. A saline soil, so this is just general salts. A saline soil has an electrical conductivity of greater than 4, right? So there are, in relative terms, quite a bit of salts here, but the exchangeable sodium percentage, or SAR, is less than 15. So of the salts that are present, it's not just sodium. There are other salts present. And the soil pH tends to be less than 8.5, and the soil may look normal, right? But if it's a saline soil, plants will likely be suffering. In terms of a sodic soil has a low EC, all right? So in general, the total amount of salts that are present, not just sodium, but all the salts that are present are relatively low. But what is present? What is present is sodium. And there's quite a bit of sodium on the exchange sites as expressed as ESP or SAR, right, of greater than 15. And these soils oftentimes have a pH greater than 8.5. And I can tell you that the physical condition when you see it is poor, right? These soils are crusted over. They have very little infiltration, percolation, and aeration, and they are poor, and nothing is probably growing on these soils. When you have a saline sodic soil, you have the double whammy. You have lots of salts, as expressed as an electrical conductivity greater than 4, and you also have a lot of sodium. The pH of these types of soils is typically less than 8.5, and the condition varies. It really varies, and it depends on the amount of sodium as compared to the amount of total salts. And sometimes the condition is poor, but sometimes it just looks normal. And sometimes it doesn't look, it looks wet. It may look wet and it may look dark, right? And I know I have some pictures to share with you that explain this a little bit better. So what I want to do is within the next several videos to describe saline soils, sodic soils, and saline sodic soils.